Okay, so yeah, welcome everyone. I guess let me share the link to the agenda. Right, so it's in the chat. Pretty much only two things today. I think the first thing is just some FastAI updates, which Lorenz can give us, and then yeah, Brian's not here right now. Maybe he'll join later, but potentially we can talk a little bit, kick around some design ideas for the parameter groups that came up. But yeah, I guess Lorenz, if you want to give us some updates, and I think maybe tell us about the grant, because this is the first time we're talking about it in a call, I think.
Right, yeah. So as I wrote on the Zulip a few weeks ago, I applied for a NumFocus small development grant. Let me see if I can find it. And I wanted to work on FastAI.jl, and it got accepted. And so until like mid of July, I have a list of things that I want to have done. And it's basically most of the computer vision functionality that the Python FastAI has. I've to make it to get a better overview. I created some issues on the FastAI.jl repo with the tag. I'm just going to share it. If you want to look at that, it's basically right now I'm working on better data augmentation for computer vision, and there's a lot of things that I've been adding to data augmentation.jl, and a lot of bugs I've been fixing, and some refactoring. And I think this will be the biggest issue of the ones tagged. And then afterwards I get to implementing more learning methods. So currently, of course, there's like the single label image classification, but FastAI also has multi-label image classification, key point regression, image segmentation, yeah, those. And then, implementing the learning method interfaces for them, creating documentation, or like tutorials that use them, so people actually know what to do. Always important. And then there are some minor features that FastAI has, which also have to be implemented. One of them, of course, as Kyle mentioned, the layer groups or parameter groups, where a model basically, or different hyperparameters of an optimizer are used for different layers in the model. And the goal here is to use it for discriminative learning rates. So when fine-tuning a vision model, usually you want to keep the pre-trained backbone at a low learning rate while you initialize the head, and then get the training started that way. And it's also applicable to model freezing, so where you don't train some layers at all. I'm just gonna paste the issue here, but we can talk about that more later in the discussions we had. Yeah, so the goal is to finish all those by mid-July, so before JuliaCon. I think there was the kind of the point of the NumFocus grant to have things that are presentable by then. Yeah, maybe done earlier. Let's see.
Cool. Are you gonna present anything on it at JuliaCon, do you think, or? I didn't know if you planned something.
I mean, the application deadline was a while back, so I didn't apply in that time. So currently it's not planned. I'm not sure, maybe the NumFocus people will mention it. Or if it's still possible to put something in. But
Yeah,
I
I
guess
was
not.
just, yeah, the deadline was some time ago, but no, I was just curious. I guess, does anyone have any questions immediately?
At some point, we should do like a blog post release announcement party thing. I guess when all maybe the computer vision stuff is ironed out, so we have one vertical that we could, that's that's ready for use.
Definitely. So the idea is to implement these features and then do a first release with everything stable. And then also, having implemented all these things, will kind of go to show that the interfaces are stable and you can build on them. That's kind of the point. And then we can also, of course, make a blog post, probably on the FluxML website, right?
One thing that I wanted to confirm was that the parameter groups that you said, they should ideally just be implementations of the way Flux does it. There really shouldn't be any difference. And as we had mentioned before, we have structural optimizers, which should be the way to go. Doing things functionally is at least proven to work out for us so far. So ideally, I would expect that to be the case with FastAI. Is that sort of how you're thinking of it as well?
Sorry, what do you mean?
So I basically mean that we really shouldn't need any, like what exactly is it that you're trying, is that you think you would want to implement in FastAI as far as the parameter groups are concerned that Flux doesn't do already?
Have you had a look at the issue?
Yeah. So I noticed that it's essentially trying to hook an optimizer to a layer effectively. So like saying use optimizer A for some layer L, and then just having a bunch of these. Is that right?
Yeah, I mean, in a general sense, but what I do for now is just have the learning rate be discounted for some of the layers, or multiplied by a factor, basically. So using a different learning rate hyperparameter for a different layer.
Yeah, I think, yeah, that specific issue, the fine-grained goal is to associate a different learning rate with different layers. But I think the generic version of that idea would be to associate any optimizer, right? So you could have different learning rates by having optimizers with different learning rates. So yeah, the most generic thing is, to be able to associate a different update rule with different layers would be the most, but that's not necessary.
Before we get into this, are there any questions on the other FastAI stuff? I also have one more link to share if you like to look at pictures of cats. It shows a little bit the new data augmentations. But probably in a few days I'll have some more stuff. And if not,
Nice.
then we can move on to.
Cool. How come no one does dogs? No one likes puppies?
I grew up with a cat. I'm sorry.
I mean, I'm more of a dog person, but I think the cat thing is okay for now.
You could file a PR to change the index in the data set and then have a puppy be used.
Okay, I might do that.
Oh yeah, also the documentation is now generated in the CI. It's not manually built anymore. And the data augmentation.jl documentation also uses the new package.
Cool.
Yeah, I guess just because Brian and Benjamin joined a little bit late, I'll quickly summarize. Laurence just gave an update on FastAI.jl. He has a NumFocus grant to work on it through mid-July, mostly focused on vision stuff and like adding multi-label image classification, key point detection, image segmentation, that kind of stuff to the repo. And yeah, I think I don't know if you can see the links that were previously posted, but I'll repost the cats.
The cat's most important part, obviously.
And then I guess the other important link, well, first, I guess, yeah, are there any more FastAI specific questions?
Thanks, Brian.
Okay, well, I guess we can continue the tangent on parameter groups, which is, I guess, the other thing we have to discuss today. But I posted a link to the issue again. The idea for this basically came out of, yeah, having a different learning rate associated with different layers or different parameters. And then I was basically just saying, okay, well, you may want more than just a different learning rate. Potentially you want more an aggressive schedule versus a not aggressive schedule, or just a conservative optimizer rule versus one that's a little bit more advanced. Those are things you might want to do, different ways of thinking about the same idea. So ideally, we'd want something that's generic enough to support more than just learning rates.
Right. So the solution that works just with the learning rates uses like the composable optimizers from Flux, as basically adds another step to the optimization where it just multiplies the gradients by a factor that's dependent on the layer that the gradients belong to, and so like discounts the learning rate. But of course, this only works for learning rate, and then we would like to, I mean, if the use case is there, I'm not sure. I just have this one use case. That's why I got started with it. But in general, yeah, having being able to customize which hyperparameters are used for which layer. And so there's, for the general case, I mean, the one way I could think of was to, it's obviously not very elegant, but to mutate the parameters of the optimizer based on the gradient. But I think that kind of goes against the idea of making the optimizers more functional, right?
So
we do have a generic implementation of changing whatever parameters you want of the optimizers and a PR in optimizers.jl already. So you could just use that.
Do you have a link to that? I haven't seen that yet.
I'll have to search for it.
Kyle, do you know which one he means?
Yeah, I mean, it's basically adding scheduling functionality. Well, it's scheduling would be the most, using a schedule would be the most obvious way to change any parameter of the optimizer. But I guess the functionality that's added, I guess, lets you do more than just a schedule, right? It lets you basically
Yeah,
it's
so
this one.
I found the link. I've posted the
Yeah.
link already. And yeah, as he said that, you know, we can basically, because we remove the state out of the optimizers, it's easy for us to, you know, change these settings on the fly, and yeah, it works.
Yeah,
You
and
can
I
do it for
think,
scheduling, do whatever with that, realistically.
yeah, and that's kind of what I was saying on the discriminative learning rate issue, is that now that the state is removed out of the optimizers, basically the actual optimizer instance itself is very cheap. It's the state that's expensive, and that only really needs to get constructed once at the start of training. So, right, so that's why I was thinking like a more functional version of the discriminative learning rates would be if we had just different optimizers for the different subsets of the model that you want to train.
So you would have a different optimizer instance for every group, right?
Right, but the state, because the state is separated out, you
Yeah.
wouldn't have multiple copies of the state.
And then if you use the same system for scheduling, you would have a different optimizer for every step.
Well, yeah, that would
Good
be
if
the
you wanted.
functional. Sorry, go ahead, Daria.
Sorry, yeah, I said you could if you wanted to, but the cleanest design that I can think of really is when you're defining your layers, you can actually just also hook an optimizer to it. So basically, like a pair, a bunch of pairs that, you know, it takes like a bunch of parameters and hooks it to an optimizer. So that could work, I guess.
Okay,
Yeah,
but
that's
then this approach, I haven't had time to look at the implementation of the pull request. But then that sounds more like if we are creating different instances based on some like schedule, then we know it's like a different way to compose the optimizers. Currently, it uses like sequencing so that one optimizer step is applied after the other, and then this would require wrapping an optimizer, right?
What do you mean by wrapping an optimizer? This would also be sequential, and it can. So basically, the idea would be that if you have a separate optimizer that basically takes in a bunch of these optimizers themselves, so you can branch it so that different parameters hit different optimizers.
Yeah, that's what I mean by wrapping, that an optimizer has to look at another optimizer, and they don't just like, because currently they're just looking at the parameters one after another, right? Irrespective of which other optimizers come before or after.
yeah, but so that, like, what they currently do, what's currently in flux, not necessarily long-term for optimizers.jl, but what's currently in flux is they look at each parameter basically one after the other, and because you're doing like a multiplicative update to the gradient, all of those multiplies just compose.
Yeah.
But the version that I think wraps the optimizer, I mean, technically in Flux right now, right, there's a optimize.optimizer. Like there's an optimizer called optimizer with a capital O, and that one does wrap.
Composition.
Right, that's a composition of multiple lower order, well, maybe not,
Yeah.
but yeah, composition of optimizers. And so that is wrapping another optimizer.
Right. Yeah. But
In
it doesn't change the optimizers, and I guess it's not an optimizer itself. Well,
I mean,
I guess.
neither with this, right? Neither with this quote unquote wrapped optimizer. This itself shouldn't have an update rule at all. It should only and only dispatch to other optimizers.
Yeah. Yeah.
Well,
I mean,
well,
yeah. It was just a question of understanding this. There's of course nothing wrong about that. But that makes
I mean,
sense. That it works well.
so the optimizer with the capital O, I mean, it does have an update rule, but its update rule is to apply
Yeah.
the update rule if it's just to directly apply the updates of the lower optimizers, the sub optimizers in order. And so, I mean, I think if you look at, like, we've had lots of long discussions in the PRs and issues for optimizers.jl, but you could think of, yeah, like lower order and higher. You could think of any optimizer as like transforming the gradient, and there's lower order and higher order optimizers where the lower order ones just directly transform the gradient. They don't wrap another optimizer. And there's higher order ones that compose the sub optimizers in some way to transform the gradient.
But what would be different here is that the higher order optimizer would like create new optimizer instances, right? Or mutate the state depending on which API is used. To set different hyperparameters for different times, right?
Right. If we're talking about scheduling and changing the hyperparameters, then yeah, the higher order optimizer would either basically the scheduler would mutate the hyperparameters or create a new instance depending on what implementation we go with.
Yeah.
But if I could go back to something that you were saying, Daria, I think you mentioned the idea of wrapping, basically pairing a group of like a layers parameters with the specific optimizer. That's basically what we were getting at. That idea, I think, is what we were getting at with having parameter groups.
So then the open PR, does it address everything that I mean, that would make it possible to implement such an optimizer, right? And then it's like a matter of how do we map each layer to an optimizer or to a, I mean, conceptually to a set of hyperparameters.
Yeah, I think that bit we can discuss separately because it's slightly a different topic, because we're at that point we have to decide what kind of APIs we need to actually mess with parameters back into the optimizers, because that's one of the things that we wanted to remove, right? So handling it explicitly is the only implementation detail that needs to be worried about. But you're right, we can write the optimizers that you want now. It's only how we want to expose that to the users that we should decide.
So is there a roadmap for integrating optimizers.jl into Flux? Or
Yep. So the PR is on Flux. It needs one more PR. Actually, there's a PR which is blocking a few different things, right? So it's the zeros PR or whatever. But that is with that we should like we're ready to integrate optimizers already. Optimizers.jl, sorry. It works with Flux already.
Oh, cool.
Wait, why does the zeros PR block the optimizers?
It's because if you want different update rules for different objects, which is kind of the objective of optimizers.jl, one of the things that we also planned on was zeros, being part of the parameter group and or not. It needs to be handled, and in its current form, it wouldn't be. It will require changes to optimizers.jl internally to make that work. Whereas with that peer, there is no change required to optimizers.jl. And that's a good thing because we cannot have, you know, all the functionality otherwise is already baked into it, into optimizers.jl. So special handling for special types is not what we should aim for here.
So you're talking about like if you try to do, if you try to initialize the state, basically the X could be a zeros. So we need to handle a case where X is zeros.
It's been a while, so I don't recall exactly if it's while initializing or while training, but yeah, as it turns out, we actually would want to represent like the optimizers should just be able to compose, and this doesn't right now.
Yeah, I mean, isn't that kind of ultimately it goes back to the issue of like what functors considers a leaf type though, right? Right now functors basically considers arrays of numbers to be abstract arrays of numbers to be leaves. But that's not always the case, right?
I mean, it really depends. So in general, you can't really say that because you would have faced the same exact issue with Zygote, which also relies on the same implementation as far as implicit parameters are concerned, but we do have accumulation for structs separately. And same goes for here, we need to accumulate structs separately. So these things don't necessarily need to be leaves in terms of what functors thinks it is, but it is part of the parameter group one way or the other. So it needs to behave as such.
Okay. Yeah, I mean, I guess the main point with the whole parameter group stuff, we kind of got off topic, but the main point was, I mean, right now you could optimize different layers. I mean, with no changes to flux, you can optimize different layers with different optimizers and or different learning rates if you wanted to.
I mean the simple change that I proposed, or the simple implementation?
Well,
Which one?
I guess if all you want to do is just multiply the learning rate by some factor, then the simple change you proposed will work. But just in general, right, I could construct two different optimizers, and I could, if I know the chain index 1 through
Yeah.
10 is the backbone and the rest is the front end, then I call params on each of those separately and store those as, the backbone parameters and the front end parameters, and you can call update with you'll just have to call update twice, right? You'd call update once to update the backbone with the backbone optimizer, and then update the head with the head optimizer.
Yeah.
So you could do that. And so I think the idea really, though, with the parameter groups is how do you make that syntactically easier to do? Right. Because right now the only way to really do it is to use the whole ID dict method, which we don't want to do.
And I think also like finding a good interface for it is going to be hard. And for the simple thing, I would just using the easy solution and just to give a FastAI like interface.
Yeah, honestly, I don't like a couple points. First off, I don't think the easy solution is that bad. For one, I think one assumption we make a lot is that your model will be one struct. It'll all be in one chain or what have you, which is fine. But I think we've seen a lot of models that don't work like that, especially the more scientific ML like ones, not SciML directly, but I don't know if I don't have an overarching term for it, but you've seen them on discourse. Another point would be that like there is a mechanism to do this, which is to use kind of like a lens, similar to what's used already for tracking mutability of state in callbacks in I think flex training. And you just define just like your model is a struct, you define something where like you take a function that finds a path of the subset of the model that you want to optimize, and then you return that and you attach it to an optimizer. That's not difficult, and it's kind of like almost a logical next step from the simple approach.
Wait, are you proposing? So with the flex training stuff, you're referring to how the learner is wrapped in a struct that manages its access, right?
Kind of, yeah. So it's something similar to that.
The model that instead of creating wrapped optimizer, you would have the model wrapped in something that.
No, you wouldn't wrap. Well, I guess it's kind of a wrapped optimizer. It's more like you have something that coordinates applying different optimizers to different parts of the model. So it doesn't need to be an optimizer in itself, though. Probably for like consistency's sake, it probably would be.
Right. So, but then the question is, so it could be implemented either as a wrapper to an optimizer or a wrapper to a model.
It does. I don't think it makes sense as a wrapper to the model.
I think conceptually, well,
because conceptually you are optimizing different groups of parameters, like different subsets of the model
So one
parameters.
example of where I'm actually already doing this, because it was an easy solution, is with freezing parts of the model. There, in FastAI.jl, I have a frozen model struct that wraps a model and basically just overrides the flux.params method to only return like a subset of the models, like to call flux params recursively, but only on a subset of the model's parameters.
Oh,
That is popped out during training.
Right. So the equivalent here would be you create I guess whatever this thing we want to call is, which has either some sort of thing like you use a flex training where you define like a similarly shaped named tuple that drills down to the level you want to optimize, or has a lens function that says like passes in the entire model structure, returns the part you want to optimize or the parts you want to optimize. And then you
Right.
don't have to wrap the model at all. Like the model is still the model.
Right, but I
Um,
mean, sorry, yeah, go ahead.
well, and I guess the one other reason to not think of it specifically in terms of the model is that the optimizer's part right now is completely distinct from what the model itself is, right? The way it works right now in Flux, optimizers just optimize, collections of arrays, and params is kind of the translation between the model and the collections of arrays. But like, if we, I linked to like a specific comment, but here, I mean, I specifically showed schedules, but it could be just any optimizer. Maps to a specific set of params, right? And I think if we were to use, so one way you could think about it is if you're using the lens interface, instead of it being just params of models, what you would pass in there is the lens for that subsection of the model. So what this group optimizer would do is then use that, it'll get in the full set of params or the full model, and then it will use the lens to extract out the params that it's supposed to associate with a particular optimizer.
Right.
but one point.
Yeah.
Yeah, so I guess what Kyle was pointing there is closer to how you would do it while constructing the model itself. And as we said, that we want to decouple that as much as possible. A second point, which is slightly different but relevant to FastAI anyway, we shouldn't be overloading the flux params function. Yeah, that should ideally not be the case for.
I think it overrides flux.trainable, actually.
Yeah, I think that is potentially more problematic, actually.
Yeah.
Ideally, we want to get rid of we want to get rid of custom trainable eventually. I don't know if it's feasible for everything, but we want to move away from that. One reason is because it completely breaks load params, just blows it up. So load params has not worked properly for months now. Well, I argue if it's ever worked properly at all, but yeah, it hasn't worked properly.
I mean, it does actually, but it's only in the recent one that it's been broken, and that's again for separate reasons. But
right. Sorry. I mean, my objection is more on the like a conceptual level rather than like implementation wise.
Yeah.
Because
I mean, as long as we stay consistent conceptually, we've had the ability to handle a lot more esoteric cases than not, and that's proven to be the way to go for us for the longest
right
time.
Because like the intention with doing more with explicit parameters is that you maintain model structure if your model is a struct, what load params does is it throws that all out the window and says, okay, just have a static vector and it has to have the same size and the same index. And it needs to be, we just assume it's topologically sorted even if it's not. Or the ordering is the topological pre-order, traversal order, what have you.
That's exactly because our parameter groups, the concept behind that was that you would have all the things that you would need apart from configuration, which you can tweak. And once we've removed bits of information from that, the parameters dump, we find these issues. But before that, it was doing its job properly.
I mean, well, I don't want to go on too much of a tangent, but I still think it's problematic when you have changes in models over time. For example, if you use a state dict in PyTorch, if you change something in model in a way that, for example, removes part of the structure, changes part of the structure, you can still load parameters in. Whereas with load parameters, you cannot. Like you can't. You have to manually map everything, remember where everything was in the tree, and load it that way.
So for that, ideally, there's the concept behind that is essentially that you've changed the model. You have to, you can if you want the state dict specifically, then you can always just store the model itself. But if that is not feasible for some reason, then you have to index into whatever loaded bunch of weights that you bring up, which is less neat but achieves the same purpose. But I agree that
Yeah.
it shouldn't be broken in the way it is right now.
I just don't see the conceptual advantage of flattening the weights into one vector before saving them, if they're going to be saved in a BSON file anyways, which already allows for structure. But I think we can debate that on another occasion.
Oh yeah.
So just to get back to what we were talking about before, this is an argument in favor of having a wrapper optimizer instead of a wrapper model.
Yeah, I think one example that in favor of like not wrapping the model is, for example, like FastAI does this in Python, is they define splitting functions for all of their vision models. And that would be similar to, it would be kind of similar to wrapping the model, because the underlying learner, I believe, looks up what splitting function to use for what model. And what that does is it railroads you into one splitting function per model. Same with a wrap model. If you want to split a model 2 different ways in the same training cycle, you have to rewrap it. Which
right. That's because it's like a global configuration that's hard coded.
Yes.
There's nothing stopping you from creating different wrappers, right?
And I mean, we can argue conceptually whether it makes more sense, from a
I would give
conceptual
one
standpoint.
more argument in favor of a wrapper model. I'm not saying that I'm in general in favor of that, but one thing is that an optimizer may be used on different models, but you would have to add the mapping of hyperparameters to it for every additional model if you want to use the same optimizer or the same wrapper optimizer. And then the optimizer, of course, has to know about every single layer that you want to have a custom hyperparameter for. At that point, it might as well wrap the model itself. So you could have an optimizer that wraps both.
I see what you mean. So like,
if you have a wrapper model, yeah, sorry.
Oh, sorry. Yeah. I think I didn't let you finish.
Where you have a wrapper model, then of course the model. In some cases, the model doesn't have to know everything about the optimizer, but a wrapper optimizer has to know everything about the model. Do you know what I mean?
Sure. I mean, the optimizer only needs to know as much about the model as is required to get the groups. Once the groups are in, then functors handles the rest.
Yeah.
And you need to know that anyways, in that sense. Like, I think part of the reason we're going to this explicit state approach for optimizers is because you can reuse the same optimizer. Like, it's not a problem. Because the optimizer is just a configuration storage mechanism. It doesn't store parameters anymore. So I don't think that is a problem.
But then for wrapper optimizer, you would again store some state.
No, the wrapper optimizer doesn't store any state inside the optimizer itself.
Or which models are associated with, like which parts of a model are associated with which parts of which hyperparameters. No?
I mean, yes, but you need to do that anyways.
Yeah, fundamentally, if you're applying a different optimizer, or let's just stick to learning rules. Let's say you're learning rates. If you're applying a different learning rate with a different subset of the model's parameters, then, I mean, you have to explicitly code in that coupling.
Yeah.
I mean, I guess what I'm saying is that coupling is inherent somewhere. Right. So like,
again,
you could feasibly have one optimizer, right, that knows about these couplings, these associations, and it doesn't need to store the state itself. It just needs to be able to grab the correct set of parameters from whatever is passed in. And if it doesn't manage, if those parameters don't exist in the set that's passed into the optimizer, then it doesn't do anything. You know, so you could have the same optimizer for different models, and depending on what's passed into the optimizer, it may or may not use all of the couplings that you defined. But
so then from a user perspective, I mean, conceptually, so let's say you're training a model for 10 epochs, and it's a pre-trained model, and for the first 3 epochs, you want to use discriminative learning rates, and then afterwards, you just want to do regular training. Intuitively, does it make more sense to use a different optimizer? So use a discriminative learning rate optimizer for the first 3 epochs and then a regular one, or to use the same optimizer but change the model wrapper after 3 epochs?
The first one.
Yeah, the first one. I would agree.
Yeah, but just to be clear, when we said the first one, you meant the change the optimizer.
Change the optimizer.
Yeah, that makes sense to me too.
Yeah, if you frame it as the optimization procedure is changing after the first few epochs.
Right.
Yeah.
Right.
Yeah. And then you also have the advantage of not changing the model and messing up load params.
Right.
That's a problem otherwise.
But yeah, I mean, not to go back to the same point that, well, Brian, you didn't want to go too far into, but this whole discussion about parameter groups to me does have to do with the fact that we just flatten the parameters into a flat array. Not just for loading the parameters and storing them, but also for what we're talking about now, some way to impart the structural information of how those parameters come together for a particular model is useful for many things. And that's kind of why, you know, I want to have this discussion on parameter groups, is because we don't have anything like that right now. And I think in the long term, we need it.
that is exactly the reason why we have optimizers.jl in the way we do. That is 100% the reason, because if you check out, I think some of the examples in XLA.jl, we have very explicit examples that go into how we see the training loop changing. We will basically be doing away with the implicit parameters to some extent, and just having the model being an explicit input. And in that case, it can be anything. We will still have the implicit parameters, of course, to actually work on very, very nested code. But from a very high level user perspective, we will end up with the structural information being part of not only your the AD, but also the optimization process.
Yeah, I mean, I'm obviously a big fan of that. So
I want to add here that regardless of whether in the end you're using a wrapper optimizer or wrapper model, as we said, the mapping of layered to group is inherent to the problem. And I think there should be some kind of data structure that makes it easy to query which group, if any layer belongs to. And then that would be stored inside the wrapper optimizer or wrapper model, but probably wrapper optimizer. And then also I think, regardless of the optimizer, wrapper optimizer implementation, there should be a nice API for creating those parameter groups objects.
So
Yeah.
Well, so if we, let's say we merge all the PRs that makes the example that Brian just shared and Daria was talking about, a reality, you could pass in the layers directly, the model directly into whatever group optimizer, and it would, right? I mean,
yeah, I mean, the way I'm imagining it now is you create a parameter groups object that just specifies a mapping from layers to a group, and then you pass that to a wrapper optimizer, and along with a mapping of group to hyperparameter.
Yeah, so this is why I had mentioned at the top of the discussion that this does require some user end changes.
Yeah.
And yeah, it's sort of separate from this discussion in many ways, because that kind of work has to happen sort of in parallel almost.
Yeah. I mean,
Yeah. So yeah, it's something that I have thought of previously as well, and just deciding on the front end for it would basically decide how we implement it. Essentially, it's that simple.
Well, I guess just one more thing, Lorenz, the parameter group structure that you described, right? Could be the lens that Brian was talking about.
Yeah. In a more specific sense, yeah.
Yeah, I mean, in its most basic form, it could literally just be a lambda that accesses the path in the thing that gets passed to it.
I mean, isn't the lens for a chain type model just the indexing of the
No,
chain?
but it could be much more complex. Right?
Please,
Right. I mean,
like if you have an MWE or something, like I would be interested in that because simply put, we can abstract out a lot of the implementation details, I feel, in this because a lens makes sense as long as we don't necessarily, overload the user. Um, I feel like that can become a bit complicated to work with for complicated models.
Yeah, for sure.
yeah. I mean, they shouldn't need to know that they're using a lens or constructing. I mean, it should be just as easy as calling params on a singular model.
Yeah, and I think there should be easier constructors also. So as we said in FastAI, you usually you split by index like a chain, and if you have a chain and that's what you want to do, then you should be able to create a parameter group that splits on indices, right? But also have any complex behavior, right?
Yeah, I think maybe my use of lens was too. It's like it's too much. It's too powerful for this use case necessarily. So like the simplest, perhaps like the most reductive way to look at it would be right now, if you want to optimize different params separately, say you have a chain with like two main parts. One is the backbone and one is the head. Then you would do like params. Head params is like the params of model one, and and then backbone params is like model two or whatever. And then in here, all you're switching is instead of saying params, you're just accessing model at one and model at two to get the different parts of the model. And the explicit parameter machinery in Flux will handle the rest for you.
So for a very traditional use case, which is just fine tuning and transfer and stuff like that, we should strongly suggest users to just pass in the parameters they want to optimize. Grouping that is slightly secondary, but if we can just make sure that the message is clear about, if you want to do fine tuning, if you want to do transfer learning, which is what 99% of the people doing any kind of DL are going to do right now, especially for big models, right? For
Yeah.
pre-trained models, that's maybe we need to advertise that more. But yeah, the correct way for it should be just send in the params that you want to optimize. That way you can never mistakenly optimize something that you did not.
Yeah, for sure. And I think to your point, like whatever mechanism we build on top of that, or we're built for this parameter groups, if it's as close to that as possible, then it also is arguably more intuitive for somebody to move to. Like say like because it's really at the end of the day, it's more of a convenience functionality to group all your stuff together so that you don't have to write your own boilerplate function to call all the optimization routines separately. And it also lets you construct it one programmatically from like a configuration file or something. That's really, I guess, that's the main use case for this kind of parameter group thing.
Okay. Well, that was I think a good discussion. I think we're approximately on the same page. Hopefully a PR, some kind of minimum working example comes out of this. But yeah, I think we're a little bit over time. So maybe let's call it for this week, and we can continue the discussion again next week if we still have a point to discuss. But yeah, I guess, did anyone have any last minute things? Okay, let me stop the recording.